We as oceanographers refer to something called thermohaline circulation, and that's the circulation that involves transfer of water from the surface in the polar regions into the deep.
So in Antarctica, where the waters are super cold, -1, -2 degrees centigrade. When it's winter, the sea ice freezes.
The first thing you need to do is drill through the ice. If you can't get to the ocean, you can't do oceanography through ice. Shoveling. Okay, so this is the main reason we're working out here. These are ice platelets, or platelet ice. You know, some of these can be 50, even 70 millimeters in size, but really quite thin, and you know, almost fresh water. Well, it is fresh. And so we think it plays a role in the growth of the sea ice. So this ice basically grows in the water column, and then it's buoyant, so it floats to the surface, or not the surface, but the underside of the existing sea ice. Then it sort of becomes amalgamated into the sea ice.
Sea ice, when it freezes, expels salt. So you're adding salt to this super cold water. It becomes super dense and then dives down to depths of 4, 5, 6 kilometers.
Deep water is forming at both ends of the planet. Right now, I think that about half of the deep water that what we say ventilates the deep ocean is happening in the North Atlantic, and the other half is happening around Antarctica.
And they set up this rather marvelous global circulation pattern, the thermohaline flow. Haline, the Greek for salt.
The ocean carries something like half of the heat that gets to the polar regions. And that's part of the thermohaline circulation, because water is flowing at the surface toward the poles, in a sense. It's cooled and sinks at the poles and then comes back up somewhere else.
Where I come from, Edinburgh, is on a fairly similar latitude to kind of Moscow or St. Petersburg almost, which are places which get incredibly cold winters. Except I, enjoy a relatively balmy Scottish winter at, 5 degrees or so. To some extent, that is as a result of water that is pulled north through the North Atlantic by the sinking action of that North Atlantic deep water. There's been times in the past when that's shut down and caused a huge, very rapid freezing around Northern Europe.
We do see changes in the ocean circulation. We do see changes in the salinity of the ocean. So at the polar areas, the waters are becoming less saline, which implies that they're becoming less dense, which in turn, if we extend that back to our discussions on the thermohaline circulation, if the density of those surface waters is starting to decrease, then we may be altering the way the thermohaline circulation operates, which means that we're altering the distribution of heat around the planet. That is a big change if it happens.
Well, if it happens that the thermohaline circulation really shuts down, this is confusing the entire circulation, the wind system and the ocean systems globally. First, what happens is you just get a strong cooling in the high northern latitudes. But it doesn't mean that we get a cooling altogether over the globe. You just redistribute the heat. So eventually you will get a warming in the south that is even stronger than what you would have from the global warming.
I mean, we can never say that we understand things well enough to eliminate the possibility that, you know, there could be a sharp change in thermohaline circulation. But I think we have many other things that we should worry about more.